Welcome to the Rich Report, a podcast with news and information on high performance computing. Today, my guest is from SolidFire, and my guest today is Dave Wright, who is founder and CEO of the company. So, welcome to the show, Dave.
Thank you very much, Rich.
Well, Dave, I've got your slides up on the screen here. Why don't we start with that, and then we'll go into some Q&A.
Fantastic. So, just have a couple of slides really to give some background on SolidFire and who we are, what we're doing, and where we're focused. And SolidFire is really a company that was started based on my experience at Rackspace and specifically my time there helping them build and launch their cloud computing effort. And really what I saw while I was at Rackspace was that traditional enterprise storage was really just not a good fit to large-scale cloud computing. From a performance, from a price, from a management perspective, it really just didn't fit into the type of environment we were building there. And that was really the genesis for SolidFire. And SolidFire is a company that is completely focused around building high-performance, next-generation, solid-state storage systems for cloud computing. The company's been around for about a year and a half now. We've got really a team of people from across the computing industry. We've got folks from the traditional hosting space. We've got people from the enterprise storage background, particularly left-hand networks, and people from virtualization and VMware as well. We're well funded. We've got about $12 million in funding to date, led by NEA and Valhalla and Novak Biddle are also investors as well. The space and market that we're targeting is very specific, and we're really looking at the hosting and service provider space, guys that are building large-scale infrastructure as a service type cloud computing environments. And within that space, we're very focused on primary storage. So there's a lot of talk about cloud storage and services like Amazon S3 and Rackspace Cloud Files and Nirvanix. And those systems and services are really all about kind of bulk storage and large archives and backup and not necessarily for primary applications. We're focused on the area of primary storage. So when the actual virtual machines are running in the cloud, what's the storage that's behind those, and where are the virtual machines and application files and databases running? That's the space that we're focused in and the challenge that we're trying to address. And really looking at the challenges that you face in that space, it really comes down to three big areas, we think, and those are performance, efficiency, and management. And on the performance side of things, you've got this huge challenge in the cloud with lots and lots of applications, lots of virtual machines, and it's just a huge challenge to deliver the performance necessary with disk-based enterprise storage systems. You can get lots and lots of capacity, but IOPS are very hard to come by, and delivering the performance you need is extremely difficult. And one of the results of that is that service providers are forced to simply throw more disks at the problem in order to get enough IOPS, and they end up with an infrastructure that has very low utilization and is very inefficient in how it uses the capacity that they've purchased. And that really leads to sprawling infrastructures that are very expensive to build and maintain and make it very difficult to have profitable storage services in the cloud. And then the last piece is really the management piece and really thinking about how service providers want to manage their infrastructure. And a lot of that is through automation, and traditional storage systems are very difficult to automate, and they put their focus on administration rather than automation, and that ends up in a very different solution and a very different set of problems that come with traditional enterprise storage when you want to put it in a large-scale cloud environment. So if you look at the system that we're delivering and the capabilities that it brings to the table, the system that we have is a scale-out storage system. It uses industry-standard Intel-based server platforms that you can cluster together in a single large managed cluster of up to 100 nodes and get more capacity and more performance as you add more nodes to that cluster. They're connected together over 10 gigabit Ethernet. They use iSCSI as the storage protocol. But I think the really unique thing about the system is that it's all solid state. We don't use any spinning disks in the system whatsoever. And the focus on solid state is really about both bridging that performance gap, but also giving a storage infrastructure that has a very small, very compact, and very power and cooling efficient footprint as well. And solid state is great for that. But I think the really interesting thing is that we've got a set of technologies and we've got an architecture that allows us to deliver a solid state storage system that can be very competitive on a dollar per gigabyte basis with most disk-based storage systems for primary storage that are out there today. And that really opens up a whole new world of possibilities because of the capabilities of flash. And in particular, if you look at the performance challenge that we talked about, we certainly have a lot of raw performance with the flash, but moreover, we've really focused on how we can deliver that performance not just to a single application, but to many, many applications running in a cloud environment. And we've developed this technology that we call performance virtualization that allows the service provider to dial in the exact amount of performance and capacity for each volume and each tenant in the system, rather than kind of having to do a best effort service when it comes to performance. This is something where they can actually dial in a level of performance and have it guaranteed to thousands and thousands of customers on the storage system. On the efficiency side of things, we really drive efficiency to very high levels through two things. One is by having a good balance of performance and capacity. They're not having to deploy more capacity just to get more performance. And so you're able to run the system at much higher levels of capacity utilization. You're able to use more of the storage you're buying. But beyond that, we've built into the core of the architecture the ability to do things like deduplication and compression and thin provisioning across the entire storage cluster in real time without performance impact. And these can lead to significant savings in space and significantly reduce the effective cost per gigabyte that you end up paying, as well as reduce the footprint of the system, the power, and the floor space and cooling as well. And then the last piece is really the management piece that we're addressing, and addressing that by thinking about the system first through the lens of automation and how cloud administrators want to automate their environments. And specifically, we've built into the system at its core a set of APIs that are completely comprehensive and allow you to control absolutely everything that can be done with the system programmatically. And delivering administration tools that are built on top of those APIs as an alternative to using the APIs, but are really not designed to supplant them. The idea is that in a production environment, much of the day-to-day operation of the system will be handled through the APIs, directly integrated with the provisioning and management systems that the service provider has. And so that's really how we address those big three challenges. At the end of the day, we've got a really amazing storage system, one that addresses a lot of the deficiencies of traditional storage in a cloud environment with breakthrough levels of performance, extremely high efficiency that brings down that cost per gigabyte, and a management layer that is really focused on automation and the needs of cloud computing providers. So that's the overview.
Well, thanks for that, Dave. I guess a question about what's going on under the hood here with these individual nodes. So you're buying x86 servers. What is the form factor that the SSDs are inside of there? Is that just the standard SSDs you might buy from someone like, say, Intel?
Yeah, so the hardware platform that we use is pretty much industry standard Intel-based server platform, and the drives we use in there are 2.5-inch SSDs. So they're not exactly the same drives you'd necessarily buy off the shelf, but they are industry standard 2.5-inch SSDs. We don't have a proprietary flash form factor or anything like that.
And then looking at this last slide, is there really any physical limit to how far you could scale with this kind of clustered storage?
Well, we've designed the system with certain constraints in mind, both to manage the design of the system as well as the testability of it. And right now, the design criteria is for clusters of up to 100 nodes, which would be a little over a petabyte in capacity and several million IOPS. That being said, we expect a lot of our service provider customers will need more storage than that, and we'll typically do that by deploying multiple storage clusters either within the same data center or in multiple data centers. So from that perspective, they can continue scaling the system by adding multiple clusters if they need more capacity.
So is there any beta hardware out there now? It looks like your early access program starts next month.
Yeah, so we're just getting ready to launch our early access program, and this is the first time where we're actually going to be putting hardware into customer sites. So we've had a number of early customers visit us here in Boulder and get to play with the system hands-on in our lab. But the first system will be going out to customers in September.
And I guess kind of a wrap-up question here, Dave. What's it like being a startup in the Boulder area, especially a tech startup? Is that a great environment there for you?
Yeah, it's really fantastic actually. The company originally started in Atlanta, and we moved to Boulder here at the beginning of the year to really get into a place where there was a better base of storage talent, and we've certainly benefited from that. This area, the Boulder and Denver Fort Collins area, has a lot of storage history, and there's a lot of storage talent available in the area. But Boulder in particular is just a great place for startups. There's a lot of startup activity here, kind of a lot of startup energy here, things that are going on with Techstars and some of the other startup groups in the area. It's really a fantastic place to have a startup.
Well, terrific. Hey, I really appreciate you coming on the show today, Dave. Um, and this certainly looks exciting, especially in the cloud and virtualization space.
Absolutely. Thanks very much, Rich.
Okay, well, that's it for the Rich Report, folks. Stay tuned for more news and information on high performance computing.